So here we have a condition that a plus b plus c adds up to pi radians. We need to show that sine of a minus sine of b plus sine of c, that's given by 4 times the product of sine a over 2 cosine b over 2 and sine c over 2. Okay, let us begin. We'll start the proof from the left hand side. So here on the left hand side we have sine of angle a minus sine of angle b plus sine of angle c. Now let's do one thing. We're going to combine the first term and the third term. So here we have sine of angle A added to sine of angle C minus sine of angle B. Now we're going to combine it using a standard formula. We are going to use the fact that if we have sine of alpha added to sine of beta, this is given by 2 times sine of the angle alpha plus beta over 2 multiplied to cosine of the angle alpha minus beta over 2. Okay, so in our case we have 2 times sine of the angle A plus C divided by 2 multiplied to cosine of the angle A minus C over 2 minus sine of angle B. Now here we're going to use the given condition. Now so it's given here that A plus B plus C, that's equals to pi radians. So what we'll do, we'll keep A and C on the left hand side and we're going to transpose B to the right hand side to get pi minus B. Now let us divide both sides with 2. This is going to give us A plus C all divided by 2. This is going to be equals to pi over 2 minus B over 2. We're going to take the sine function of both sides to get sine of A plus C over 2. That's going to be equals to sine of the angle pi over 2 minus B over 2. Now we have sine of the angle A plus C divided by 2. This is going to be equals to, now what is sine of pi over 2 radians minus some angle which is B over 2. This is going to be cosine of the angle B over 2. In other words, if we use this condition that a plus b plus c equals to pi, then we can say that sine of a plus c over 2 is going to be the same as cosine of b over 2. Okay, so let's use that. We get 2 times. Now in place of sine a plus c over 2, we'll get cosine of b over 2. Next, we have multiplied to it as cosine of a minus c over 2 minus, now we have sine of b. So what we'll do, we're going to expand sine of b. Now there is a standard formula for expanding. Let's say if we have sine of angle theta, this is given by 2 times sine of the half angle theta, half of theta, and multiplied to cosine of half of the angle theta. So this is the half angle formula. So here in place of sine b, we can replace it with 2 times sine of half of angle b multiplied to cosine of half of angle b. Now from both of the two terms, what we can do, we can now pull out 2 times cosine of b over 2 as the common factor. So this is going to get multiplied to cosine of a minus c over 2 minus sine of the angle b over 2. Okay, now as you can see, cosine of b over 2, we have factored out this term. Now what we need to do is we need to find out the product sine a over 2 with sine c over 2. For this, what we'll do, we will need to combine these two trig functions. But the problem here is one is a cosine function and the other is a sine function. We want both of them to be the same. That means if one of them is cosine, we want the other to be cosine. Or we can say if one of them is sine, we need to convert the other to sine. Only then we can add or subtract the trig functions. So what we'll do, we'll try to convert the second term sine b over 2 to cosine function. So again, we will use the condition. So here, let's again use the condition that since a plus b plus c, that's equals to pi radians. So what we can do, we can get b over 2 as pi over 2 minus a plus c over 2. So what we're going to do is take the sine function on both sides. So sine of b over 2, this is going to be equals to, we'll take sine of pi over 2 minus a plus c over 2. That's going to give us cosine of a plus c over 2. Okay. So now what we have is 2 times cosine of angle b over 2. This is going to get multiplied to cosine of the angle a minus c over 2 minus cosine of angle a plus c divided by 2. Okay, fine. Now what we have is the difference of two cosine functions. So here we're going to use the fact that cosine of alpha minus cosine of beta. So this is given by 2 times the product of sine of beta plus alpha over 2 multiplied to sine of beta minus alpha over 2. So here let us suppose a minus c over 2 to be equivalent to alpha and a plus c over 2 to be equivalent to beta. Fine. So that means our expression is now going to become 2 times cosine of the angle beta over 2 multiplied to, so here we will get the factor 2. So this is going to get multiplied to sine of, so what we need beta plus alpha. That means we need a plus c this over 2, this is beta, added to a minus c over 2 whole divided by 2. So this is going to give us a over 2. So we have sine of a over 2 multiplied to sine of, so we need beta minus alpha. So if we take a plus c over 2, which is beta, and from here subtract a minus c over 2 divided by 2, that's going to give us b over c over 2. C over 2. So we will get sine c over 2. So finally we get 4 times sine of the angle a over 2 multiplied to cosine of the angle b over 2 times sine of the angle c over 2. And this is exactly the expression on the right hand side. So let's verify. So we have 4 times sine a over 2 times cosine b over 2 times sine c over 2. So here we have successfully verified. Hence we have verified that the left hand side equals to the right hand side. Hence proved.